In the first part of this tutorial, we found the coefficient of static friction for this aluminum sculpture. Now what we want to do is find the coefficient of kinetic friction for the same aluminum sculpture. So we proceed the same way. We want to draw our free body diagram. We're on the Earth, so there's gravitational force present, and that's always down. We are on a surface, so there's a normal force perpendicular to the surface, meaning straight up. And there's also friction. Now, if we were to push this statue to the right, the friction would be to the left. So let's draw it as such. And it is moving at a constant velocity. That's important here, constant velocity. So since it is moving, that is kinetic friction. Since it's a constant velocity, that means that it's in equilibrium, which we'll use later on. We are applying a force, takes a force of 670 newtons, so we'll push to the right 670 newtons, to keep it moving at that constant velocity. Now, what are we given? That's the next step. Write down our mass, 145 kilograms. So as long as you see kilograms, you automatically know that that's a mass. We also know that we are applying that force of 670 newtons. And we want to find the coefficient of kinetic friction, mu sub k. Now, one hint here, whenever you're given mass, the first thing you want to do is calculate the gravitational force. So we'll go in here, the equation for gravitational force, if we go to our equation, is right here. And the gravitational force is the mass times the gravitational field. So gravitational force, m times g. The mass is 145 kilograms, and gravitational field constant is 9.81 newtons per kilogram. So it's really just a conversion factor there, that gravitational field constant. We multiply those together, and we get 1,422.45 newtons. So that's not what we're after. If we go back here, we see that we're after the coefficient of kinetic friction. We go to our equations, and there's only one equation with the coefficient of kinetic friction right here. So that's what we have to go to. There's no other choice. Kinetic friction is the coefficient times the normal force. I'll put a box around what we're finding. So we see that we don't know either the kinetic friction, nor do we know the normal force. We know the other two, we don't know those. So now we go to our conditions of equilibrium. Again, we're at constant velocity. So what we can do is write down, we always go to the same two equations when we're in equilibrium. Total force in the x is 0, and we also know that the total force in the y direction is also 0. So looking at the forces in the x direction, there's two of them. There's kinetic friction and there's applied force. So the sum of those forces is 0. The kinetic friction was to the left. So what we want to do is put in our positives and negatives at this point. The kinetic friction was to the left, that makes it negative. The applied force was to the right, so that is positive. I'm going to change that. Now we do know the applied force, and the applied force is 670 newtons. Solving for the friction, we get the friction to be also 670 newtons. Remember, they balance each other out. Then we go to our conditions of equilibrium in the vertical direction. And we see there's two forces in the y direction, the normal and the gravitational. So let's add those together. So we have the normal force and gravitational force. We want to put in our negatives where applicable. So normal force was up, well, that was positive. Gravitational force was down, that makes it negative. Now we know the gravitational force, so we can use this equation to get the normal force. And we have that the normal force is also 1422.45. So now we know both the kinetic friction and the normal force, which was necessary to solve for our coefficient of kinetic friction. So kinetic friction is 670 newtons. Our normal force is 1,422.45 newtons. We divide them and we get the coefficient to be 0.47. Now, if you remember from the previous tutorial, the coefficient of static friction was 0.61. So the coefficient of kinetic is less than that, which is what we would anticipate based on our previous information.